Hello and welcome to today's webinar. My name is Tyler Reed. I'm the Manufacturing Applications Manager here at GoEngineer. And today I'm going to be talking about printing scale models with color. So printing scale models, what does it mean? Well, essentially I wanted to do a webinar topic about scaling models up or scaling models down in anticipation for 3D printing. So we're talking about parts that are printed at a different size than they normally would be designed and some of the challenges that come with that. Also, because we're now printing with color with the Stratasys J750, we've got full color capabilities. That becomes popular when we start talking about figurines or scale models that are being used for appearance purposes. So one of the things that is super important when you go to get a model printed at a scaled up or scaled down size is you have to be familiar with the printing process that you're going to use. There's a lot of ways to 3D print parts, from FDM to PolyJet to SLA to SLS, powder bed um, machines and fusion binder machines, all sorts of different ways to 3D print parts. And each type of technology has different advantages and different disadvantages and different capabilities. When you're scaling down, a lot of times minimum feature size and minimum wall thickness come into play. The resolution of your prints. Also, if you are scaling down assemblies that have moving parts, then clearances between those parts becomes an issue as well in X, Y, and Z. So that's going to be one topic that we tackle here. The second topic is going to only apply to people printing color versions, different ways of applying colors, and what are the advantages and disadvantages of those. A lot of this information I'm about to discuss, I go deeper into in a webinar that is already on our YouTube page. It's called Design for Print. But we're going to go ahead and discuss this now. So we obviously deal with Stratasys and we have the FDM and PolyJet technologies. Each of those has different feature size capabilities. When it comes to holes, slots, and bosses, they each have their own minimum size. And sometimes that size depends on what thickness you're slicing the model or what quality setting you're using in the case of PolyJet. Also, what affects it in PolyJet is the surface finish you select, whether it's matte or gloss. Matte finish tends to give you higher resolution, or I should say better tolerances, but a gloss finish usually will give you better through holes or through slots and bosses. So that's something to keep in mind. If you're working through a service bureau, ask a lot of questions when you go to get a part printed. If you don't ask questions and if you don't make the service bureau aware of your needs, then a lot of times you're not going to get the best part that you could have. Another thing that comes up is minimum wall thickness. On FDM, when you go with thinner slices, you're going to have the capability of using thinner walls. The minimum recommended wall thickness is listed in what we call roads, 2 to 4 roads. These are essentially paths, okay? So you could go down to as thin as maybe 30 thousandths on an FDM at the minimum recommended. On PolyJet, minimum wall thickness is, again, right around 30 thousandths. Of course, the taller the walls, the thinner you're going to want to go. Clearances is another issue that comes up. When you're printing parts that have multiple bodies in them and you're printing them in hopes that they'll be separated and have movement relative to each other once they come off the build envelope, then you have to make sure that you give them enough clearance so that they don't bond together. Both PolyJet and FDM are capable of this. Minimum recommended clearance I have listed here is either 8 thousandths between the walls or one Z layer. So 8 thousandths in X and Y, or one Z layer or one slice height in FDM. And then it's actually a little bit wider on PolyJet. 10 thousandths would be my recommendation, or 5 Z layers on PolyJet. Now, if you're printing in matte on PolyJet, you can go down a little bit farther. You could probably go down to about 7 thousandths clearance and still get away with the parts not bonding. But if you go to gloss, you want to get at least 10 thousandths. And we'll see the results of maybe breaking that rule here in a bit. And lastly, how do parts fit together that are intended to maybe interact with each other? Like in this case, we have some bosses and some parts spinning on those bosses if they're printed separately. And so what is your radial clearance? And I have a nice little chart here. You got PolyJet, gloss or matte, FDM, X and Y, or X and Z. And the radial clearance corresponds to the type of fit between interference and free fit. Having example parts, like I've shown in these images, available for you as a designer or your team who's designing parts to be printed is invaluable. Otherwise, you're going to be printing parts that come back not as you want. And it's going to take 2, 3, 4, maybe 5 different iterations to get it right if you're just going through trial and error. Or if you have example parts like I show printed out, you can quickly test. So that about covers the design considerations for scaling up and scaling down. Let's talk about color. When it comes to the Stratasys PolyJet line, we do have the ability to do color. The color can be as simple as single solid colors, and it can be as complex as gradients and full color maps. There's different ways that you're going to apply the color in the model based on your desired outcome. Different materials might specify or require that you do it one way or the other. The most basic way is coloring with shells or separate bodies. You're going to have one color per body. You're still going to output the STL file format. STLs are a generic 3D printing file that doesn't contain any color data. So all the colors are assigned in the printer software. And so the way you do that is you have a separate body. You just apply one color per body. When it comes to PolyJet, if you have any sort of transparent parts or translucent materials, you're going to have to use this method, shells. If you're using the rubber-like materials, again, it's going to have to be bodies. And also digital materials like digital ABS. So for example, in this push button model, since we have a button there that has some translucent green, since there is a gasket that's rubber-like, you're going to want to output an STL and do the coloring inside PolyJet Studio. Here's an example of some figurines that I printed actually just this week. You can see they're quite small and they have basic colors. These were all each single body parts. The chests were printed in brown and the figurines were printed in a gray. And I simply used STL files and assigned the color, the RGB values that I wanted in PolyJet Studio. You can see here where PolyJet excels in small scale parts. We have a lot of detail in those figurines and they're smaller than a quarter. The second method for coloring is coloring with faces. So this is going to allow us to have multiple colors on a single body, potentially. The output is VRML. And I should say the input into PolyJet Studio is going to be VRML. And you can use one file per part, or you can actually have an entire assembly, multiple parts, under one VRML file. In this case, you're actually doing the colors in your CAD tool. So I'm going to go through an example here in a bit where we walk through the SolidWorks workflow for applying colors to faces. The limitations when it comes to PolyJet, we're going to be limited to Vero materials only, so no rubber-like materials, no digital ABS, opaque only as well, so no Vero Clear. And we have some limitations. SolidWorks and other CAD tools, when they output VRML, they are only looking at the colors of faces. So when it comes to things like decals or images, those don't get output. So we're going to talk about how we might handle, in this case, that splatter logo. This is a robot toy that I did recently for the BattleBot team Splatterbot. This was a 36-inch model I was given, and I had to print 3-inch wide toys that had moving parts. And so I had to walk through a lot of the steps that we're going to discuss here in a minute about redesigning for a scaled down version. Here was the final output of that color by face. So you can see this is, it's got some unique colors, but in the case of that orange cover, it's one body, but we have multiple colors on it. We go through that in SolidWorks, doing the color by face. So let's jump into SolidWorks and talk about some design tips and also the coloring tips. I created this really basic cube to just discuss some of the tools that I commonly use when it comes to scaling models up or scaling models down. When it comes to clearances or maybe walls that we need to widen, one of the best tools is a direct editing tool called Move Face. You find that under the Mold Tools tab, Move Face. And what Move Face allows you to do is click on faces. And for some reason, it's thinking a long time about this particular face. Allows you to click on faces and avoid the sketch step if we simply want to make parts smaller or larger, or just move or translate faces. So in this case, I'm offsetting these faces. You can also translate or rotate faces. We can flip the direction. So you can see that changes the preview. So I can instantly make this cube smaller or larger. Now this is commonly done on holes. When people create parts, say on this 36-inch part, they might have only designed 20 thousandths clearance between a shaft and a hole it's going through. But if I'm going to scale it down, in this case, this toy, I scaled down 12x, that 20 thousandths becomes something like 2 thousandths, right? So that's obviously not going to work. So I might scale a hole up or scale a shaft down by using this move face option. And that avoids me having to create a sketch, maybe using convert entities, making it construction line, offsetting, and then doing a cut. Much easier to just use move face. Okay. Obviously, we have the scale function. I don't recall where scale is. It looks like it is in the mold tools. If you ever forget where a tool is, you can use the search box up in the top right-hand corner. You can start to type in this case, scale, and you can scale it. If you're scaling multi-body parts or assemblies, make sure that you pay attention to what you're scaling about. A lot of times the centroid is not what you want. Maybe it's the origin or a particular coordinate system. You can type in math equations here. So if I wanted to scale a part down 12x, I can do 1 divided by 12. And it will do the math for me. It's 8.33%. Scale that guy down. Okay. Move face is one of my most commonly used tools when I'm scaling up and scaling down. Another thing I use a lot is combine. So if I were to create another body here on this face, We'll just make it small. And I uncheck the merge result. I end up with multiple bodies. Okay, so I can hide this and I'm left with this. Multiple bodies. Now, when it comes time to print, or even prior to printing, if I am scaling up or scaling down, if I know I don't need any movement between parts, a lot of times I'll use combine to merge parts together or merge bodies together. So combine, and we'll use the add option, and they become a single body. Okay. If I'm scaling down and the parts aren't quite touching, uh, but there's not going to be any relative movement between them, then I might extend a body into a second body and combine them there as well. So if let's do an example here, we'll offset this guy, say 2 thousandths. Notice my combine failed now because there's actually a 2 thousandths gap. Well, that might weaken the print. So I'm probably going to want to handle that. And what I might do is, again, use the move face option. And offset it enough to interact with this body. Okay. So if I offset it 3 thousandths and move my combine down after the move face, now they're combined because they were intersecting and then I combine them. That combines them into one. When it comes to colors, as I mentioned, we can do colors of faces. So when you do an appearance in SolidWorks, you can apply a color to a face. And you click each face to apply the color. If you apply the color to a body or the whole part or a feature, when you output the VRML file, the color will not come through. Okay, so it has to be to the face only. Now, how do we get complex colors? Well, that becomes difficult. A lot of people, what they first want to do is use decals. So decals can be found under the Appearance tab. Under decals, you can load up your own decals. So we might put a decal on that face. That was nice and easy, but that does not come through in the VRML file. So things like logos or stickers, you're going to have to do something else other than a decal or an appearance. An example of an appearance might be a carbon fiber appearance, something like this. That looks great, but that will actually not come out in a VRML file. So how do we deal with it? Well, we have to create faces where we want to create colors. So what I might do is create what's called a split entity or a split line. If I sketch on this bottom face, the pattern that I want, we'll just do a quick mock-up of our UL symbol. Okay, obviously not accurate, but it's a sketch on that face. It could be hovering above a face as well if we had a curved surface. Under the Features tab, Curves, we have something called a split line. And what a split line allows you to do is project a sketch onto a face and it splits it. So now we have individual faces that we can interact with. So I can apply an appearance to this face, make it black, that face and that face. that will come out in a VRML file. Okay? So if you're doing your coloring in SolidWorks, this would be one way to do it. Now, when it comes to this carbon fiber appearance, we actually have to go outside SolidWorks to do that color. We can do it in Photoshop CC. We can do it in Blender is another software that we use. You would read in an STL file and apply images to surfaces. So let's take a look at this toy model. I'm going to do a feature search, move face. You can see I use the move face option several times in this model. Now, if I search for scale, I don't get any features. Okay, so this part, if I just do a quick measurement from this face to this face, it's almost 37 inches wide. So this is actually the full size model. I decided to do the scaling in the printer software. So I designed this part to be scaled later. Now, you don't always have to do that. You could scale first and then go through and make sure all your clearances are correct. And that might be the more straightforward way. Instead, I knew I was going to scale it later on. And so what I did was when I created clearances like between this shaft and this hole, is I did 12 times the clearance I knew I needed. Okay, so in this case, I used 7 or 8 thousandths clearance between all the moving parts. I did something like 54 thousandths clearance. Okay, we could actually, can't look at the clearance there. But I did the clearance in anticipation for scaling it later. That's important. So parts that are meant to move in here are the wheels. Each wheel is meant to move. This arm is meant to move up, and this guy is meant to spin in a circle. Okay. And none of those had proper clearances. So in this feature tree, I went through and made all of those clearances using, in most cases, move face. If we look at a cross-section view, we start to look at some of these wheels, you can see some other things that I did. In the original model, these wheels actually had some interference. So I had to create a revolved cut around this wheel to give it some relief. Notice these shafts all have the proper clearance, but I will say, because of the way these shafts are hidden, they're very well hidden, tucked away. When those clearances got filled with support material, it was difficult to remove. And the wheels never fully spun freely. So that's something I probably should have taken into account. The support removal was going to be difficult. There's not a lot of access there. So I probably should have bumped it up to maybe 12 thousandths clearance. Now the wheels would have been a little bit looser if I got all the support out, but chances are I wouldn't. So it probably would have spun more freely. Now let's talk about how I created the split line for these colors. Obviously, it's a very complex split line. I was given a PNG file similar to a JPEG file of their logo. So you can see it here. This is just a dumb image. If I zoom in, you can see it's a raster. It doesn't scale well. There's no info for me to pull off of it. So here's a trick to actually be able to use that. And I say actually be able to use it because in SolidWorks, when it's just a visual representation, I can actually just grab that image and pull it onto a face. Okay, I can do that. And in SolidWorks, it's going to look great. I can edit it. I can scale it. I can actually just tell it to fit. Okay, and I might get it to look good on my model, but again, it doesn't get output, so it's not usable for 3D printing. It would be usable for rendering or drawings, but not 3D printing. So what we end up doing is we convert that JPEG to a vector. And the way I do it is the cheating way. Online, there's a website called vectorizer.io. It's a super simple way to upload a JPEG, a PNG file, or a bitmap and have it convert it to vector. You simply say upload image, select your PNG. It gives you the options for some wizards. I'm going to go ahead and say just skip the wizard and use this setting. It outputs it. The cool thing here is if we zoom in on it, you can see now these are hard lines, okay? And vectors are actually going to give us the path for the outlines. And we're going to be able to convert that to a SolidWorks sketch. So you simply say download, and that's it. It's free. You can use it, as far as I know, all day. Very awesome and quick. That outputs a vector file. Now we need to get the path information into SolidWorks, and we do that through a DXF file. Now there's a step here. We have to convert the vector file to a DXF. I do that in Illustrator, but you can also use a program called Inkscape, which is a free vector tool. I use Illustrator CC, but if you don't happen to have that, use Inkscape. What this allows you to do is open your vector, and you can get data on the paths, okay? So if I highlight these paths and we zoom in here, not perfect, but good enough in this case, okay? I simply highlight it and go File, Export, and select a DXF file as the export, and that will create this file. Then in SolidWorks, we're going to open the DXF. We're going to select to import it as a new part and a 2D sketch within that part. When you hit next, you do have the option of selecting the import units, inches, millimeters, and hit finish. It's going to open up a new part, and it's going to start a sketch with your vector paths. Look at that. Cool. SolidWorks is notorious for struggling with sketches that have a lot of separate line segments. So one thing I do recommend if you're going to interact with this, say move it around, or if you want to lock it down so that it doesn't explode on you, use what's called a block. Say search for make block. And it allows you to create a single entity out of all of the separate sketch entities. And SolidWorks will run a lot faster when it comes time to actually create the split line or if you're trying to move these parts. Now you can't scale, rotate, mirror a block. And so sometimes after you create a block, then you use the explode block option to turn it back into sketch entities. We are in a separate part, but I can actually just copy and paste this sketch into a new part, and then I can use the split line to create the faces that I need to color. So that's the workflow for using a JPEG file. to color an image for 3D printing. We have to go to JPEG, to vector, to DXF, to sketch, to split line, and then you finally color the faces. So it's convoluted, but there is a pathway, and it's relatively painless once you get the hang of it. So there's my sketch. When I'm in edit sketch mode, I would simply highlight the block, hit Control C, change parts, start a sketch. So I'll start a sketch on this face. Let me actually copy it. And then hit Control V and paste it. Now notice it came in, it would have to be rotated. So we can use move entities, copy entities, rotate, scale, and stretch to get this placed how we want it. And then we use our split line. So if we just take a quick look at my feature, it's here. The sketch looked like these. Simply split it, and then you go through the, in this case, a little bit arduous process of assigning colors to all the faces. Now, once every face has a color, and we have all of our proper clearances, then we can do a file, save as, change the save as type to VRML. Once you change the save as type to VRML, definitely check the options and make sure that you have VRML 97 selected. It's the older VRML type. It is the one that's used in PolyJet Studio. So you'd save a VRML file. VRML is similar to an STL, but it contains color data. And then you can either send the VRML file with to your service bureau, or if you're doing the printing on your own, you would open PolyJet Studio. This is the software that we use to arrange parts to be printed on the newer PolyJet machines. Insert VRML file. In this case, remember I hadn't scaled it yet. So the part is much bigger than my build envelope, but I can very easily scale it within this software. So I come down and scale it by 8.33%. And I will just tell it to do an auto placement. Okay. Notice it placed it upside down. I'm printing it in matte finish, which means it's going to fully encase the part in support material. Direction does not matter. PolyJet is not very directional. You're not really going to see a difference if I printed it upside or downside. And if I was printing it in a gloss finish, I'd want to flip it over so that I don't have any support touching the outward surface, the surface that you're actually going to see. Because if support is touching a surface, it will end up with a matte finish. If I want to print multiples of these, I can select to copy them, etc. So once you bring it in, you scale it, you place it, select as many as you want to print, you send it to the machine, and you're good to go. Very quick process. We should touch on this. I mentioned it. I'm not going to go into detail, but remember when I talked about applying that carbon fiber color to a model? You're going to have to go into Photoshop or Blender or maybe Rhino, another CAD tool. There's other ways of creating complex colors. One of them is with 3D painting. We generally do this in Photoshop, but you would load in an STL file and then use all the Photoshop paint brushes and tools to actually paint onto a 3D model. This is necessary for if you're going to do something like a lion here and you wanted to be able to paint details, color details into the model, you generally would do it into the 3D model. A second way of doing it within those softwares, if you want to apply images and not go through the hassle of what I just did with the split line, then you might go into Photoshop again or Blender and pull what's called a UV map. And a UV map essentially unwraps the surfaces of the model into a 2D image, and then you can place your decals, your images, and colors onto that 2D UV map. I'm not going to do it here because it didn't apply to the Splatterbot toy, and it is a more involved process than what I just did with the split lines. So if you can get away with split lines, that would be the way to go. But this is necessary for if you're doing textures and gradients and complex color schemes like you see here. So this is the Splatterbot toy once it was printed. This is the gloss finish. So you can see the top surface is very glossy. But notice that the arm is not moved out of position. That's because it's stuck, okay? So I gave it, I believe, 7 thousandths clearance for this arm. And if there was only a little bit of surface area between the two parts, I might have gotten away with it. But with the larger amount of surface area, it didn't put any support material between the two. They actually bonded. I should have done probably 10 thousandths minimum. On the matte version, it does move. It does have enough clearance because in the matte version, it actually puts a layer of support material between the two surfaces. And that support material is very soft and waxy-like, and you're able to break the bond. Okay, so there is a difference between matte and gloss when it comes to clearances. But notice the rest of the part is a little bit matted, right? It doesn't have that nice glossy surface finish. We ended up printing about 40 of these bots, and we sent them to the Splatterbot team. They were really happy with them. But this is what it looks like when we printed a full run of these guys. We print these overnight, and we were able to print about 24 of them at a time. So pretty good for short run, kind of nice giveaways for this Splatterbot team. And that does it for our presentation on printing scale models. Remember the important things to think about is, first ask, am I scaling it up or scaling it down? Do I have features that are going to become concerns? Are walls going to become too thin? Am I going to lose clearance between moving parts? And address those. Okay. And when it comes to color, depending on how you want to do the color, you might be coloring separate bodies, you might be coloring faces, or you might be pulling it into Photoshop and doing the coloring there. If you're working with a service bureau, make sure you send them the file and ask them what they would prefer or what they would recommend. If you're working with us here at GoEngineer, we'd be happy to give you some recommendations as to what's going to be the best workflow for you. Okay, so thank you guys for joining. If you have any questions in the YouTube, just type them into the comments and I'll address them. Thank you guys for joining live, who did, and I'll see you next month.